All right, so our force of friction is equivalent to mu k times n, the normal force. So Fk equals mu k, which is 0.1, and there are no units there, times the normal force of 0.35 newtons, which would be equal to 0.035 newtons. Now, the sum of the forces in the x direction is equivalent to mass times the acceleration in the x direction, and the sum of the forces in the y direction would essentially be equal to n minus mg cosine theta, but that would simply be 0 in this case because the adapter is not going up nor down, it's simply staying level on the y-axis in respect to the x-axis of the inclined plane. So the sum of the forces in the x direction is the mass times acceleration. So we're going to find the acceleration, and we're going to do a calculation with that. So sum of the forces in the x direction equals mass times acceleration. So the first force is Fk. That is the most obvious. However, we must add mg sine theta, which is the x component of the weight of this adapter. So plus mg sine theta equals mass times acceleration. So we already know the force due to friction is 0.035 newtons plus mg sine theta, which would be equivalent to 0.35 newtons. And that would equal the mass of 0.05 grams times the acceleration. So our acceleration would be 0.035 plus 0.35 divided by 0.05, which would be 7.7 meters per second. Now, I'm just gonna give you a sample calculation to show you the types of things we could solve with this. So we could take this into a broader, we could reach into other topics other than just forces. We can actually work with some kinematics. So let's say I shoot this up here at 2 meters per second. I shoot the adapter up 2 meters per second, and I want to know how far up it'll go. Now, this kind of thing could be useful, for example, on a roller coaster, to find out the velocity we would send a roller coaster car up on an incline on a boomerang type roller coaster to ensure that it doesn't fly off or go too low and not deliver very much in terms of thrills. So we can set up a kinematics equation. We're going to be given the final velocity of 0, the initial velocity of 2 meters per second. However, we're going to call that negative 2 meters per second because we'd be shooting it up in the negative x direction, up towards the top of the incline. And the acceleration of 7.7 meters per second. And we are trying to find the delta x